day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to talk about solving zeros of a quadratic function using extraction. Now, before we proceed to our video tutorial, make sure that you already know how to simplify radical expression. Now, on to our video. Let's talk about zeros of a quadratic function. So, zeros are commonly known as the x-intercept, a point of the graph when y is equal to 0. It is the point of the graph that is along the x-axis. So again, it's part of the graph that touches the x-axis or that passes through our x-axis. Quadratic function can have no zeros, 1 0, or a maximum of 2 zeros. In solving zeros of a quadratic function, one of the possible methods to use is using extraction. Now, in using extraction, we're going to use a property called the square root property. So, in square root property, if x squared is equal to n and n is greater than or equal to 0, then x is equal to positive negative square root of n. Now, in this case, we're going to use this square root property to remove the highest exponent 2 to our equation. So it is also common to indicate the positive and negative solution by writing plus minus square root of n. So here are the steps in solving zeros of a quadratic function using extraction. So first step is to change the variable y or the function notation to 0. Second step is to isolate the variable x. And step 3 is for you to use the square root principle or the square root property. Now, take note, you can only use this method if and only if your given function is in vertex form or if you're given only one variable x in your function. So here are some examples in solving zeros of a quadratic function using extraction. Alright. For example, we're going to get the zeros of this function. So first step is for us to change our function notation to 0. Then, we isolate the variable x by transposing negative 16 to the other side of the equation. So we have x squared is equal to 16. So since we have our exponent, we need to use the square root property. So we get the square root of both sides. So the square root of x squared will be x and the square root of 16 will be positive and negative 4. Again, take note, it is important to indicate both positive root and negative root of our radical. We will have x is equal to negative 4 and x is equal to 4. Therefore, our zeros will be negative 4 and 4. Alright, or let's have another example. So for example, we're going to get the zeros of this quadratic function. So first step is for us to change the function notation to 0. Then, we isolate the variable x. So let's transfer negative 81 to the other side of the equation. It will be square root of the sum of x and 7 is equal to 81. Then we get the square root of both sides. Now, when getting the square root of a number, we get the positive and negative root. So, we have x plus 7 is equal to positive negative 9. So, that's the square root of 81. Then, from there, we transfer positive 7 to the other side of the equation. So, we will have x is equal to negative 7 plus minus 9. Since we have two operations for 9, we have plus and minus, we will separate them. So we have x is equal to negative 7 minus 9 and x is equal to negative 7 plus 9. So we solve for the value of x for each equation. So we have x is equal to negative 16 and x is equal to 2. So for our zeros of our quadratic function, it will be negative 16 and 2. Alright, let's have another example. So for example, we're going to get the zeros of this quadratic function. So our first step is to change the function notation to 0. Then from there, we isolate the variable x. So we transfer negative 48 to the other side of the equation. We will have 2 times the square of the difference of x and 3. And then we divide both sides by 2 to eliminate the coefficient 2 in our left side. So dividing both sides by 2, we will have the square of the difference of x and 3 is equal to 24. Then from there, we can now remove the exponent by getting the square root of both sides. So finding the square root of 24, we will have positive negative 2 square root of 6. Again, we will get the positive root and the negative root of square root of 24. We transfer negative 3 to the other side of the equation in order for us to isolate our variable x. So we will have x is equal to 3 plus minus 2 square root of 6. So we have two values of x. We have x is equal to 3 minus 2 square root of 6, and x is equal to 3 plus 2 square root of 6. So that will be our zeros of our quadratic function. Take note that we cannot combine 3 and 2 square root of 6 because they don't have the same radical. Okay? Therefore, our zeros of this quadratic function will be 3 minus 2 square root of 6 and 3 plus 2 square root of 6. Alright. Okay, so let's have our last example for today. So for example, we're going to find the zeros of our quadratic function. So first step is for us to change the function notation to 0. And then let's isolate the variable x. So let's transfer positive 40 to the other side of the equation. We will have 2x squared is equal to negative 40. Now, let's divide both sides by 2 to eliminate the coefficient of x. So we will have x squared is equal to negative 20. To remove the exponent, we need to get the square root of both sides. So let's get the square root of negative 20. So in getting the square root of negative 20, take note that we have a negative radicand. So we will encounter an imaginary number. So we will have x is equal to positive negative 2i times the square root of 5. So we have two values of x. We have x is equal to negative 2i times square root of 5, and x is equal to 2i times square root of 5. Now, our zeros will be negative 2i square root of 5 and 2i square root of 5. Alright. A little reminder, if you're going to use extraction as your method of solving zeros of a quadratic function, it is only effective if you're given a quadratic function that is in vertex form, or if your quadratic function has one variable x. Okay, if you have two or more variable x in your quadratic function, you need to use a different method. Now that you already know how to solve zeros of a quadratic function using extraction, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace.